All right, so I'd like to say a little bit about the way Venus appears from Earth. It's kind of important because as an astronomy person, I get pretty regularly a question, what is that thing I see in the west at sunset? It is so bright, and I can't believe it. It's so bright, I can't believe it's actually not a plane or something. It's always Venus. And as you go forward in your lives, this will happen to you. You'll look to the west after sunset, and you'll see a very bright thing there, and it's Venus. And I want to talk about why it's so bright and why it shows up in the evening like that. Because you'll never see it at midnight. You'll never see Venus at midnight. You only see it right after sunset or right before sunrise. And I want to say why that is. Okay, well, Venus is very bright because it's covered in clouds. It's covered in bright white clouds all the time, like I said in video number 41. Also, it's quite large and it's pretty close to the Earth. So it's the brightest thing up there other than the sun and the moon. In dark places, you can see Venus shadows. Okay, and you don't need a special eye to see it. It's quite obvious. If Venus is out, the moon is down, it's nighttime, and you're in a very dark sky, you can see Venus shadows. Okay, that's how bright Venus is. So if we're on the Earth, this is us here, and there's the orbit of Venus. As Venus goes around the sun, there's a couple of points in its orbit that are really important. Let me draw a line, reference line here. So the reference line there. When Venus is here, it's known as inferior conjunction. I didn't write out the word inferior because it would take up the whole picture. So it's on the line between the Earth and the Sun. It's known as inferior conjunction. Out here, it's known as superior conjunction. A conjunction is what you get in astronomy when an object is in the same direction as the Sun. So whether it's Venus, whether it's Mars, whether it's the space station, doesn't make any difference. As long as an object is in the same direction as the Sun, you call that conjunction. And in the case of Venus's orbit here, right, this is Venus's orbit here, there are two conjunctions. The one that's closest to the Earth is inferior conjunction. The one that's furthest from the Earth is superior conjunction. And there's two other points that are important to note. If we draw a line here, tangent to the circle, so it just grazes the circle that way, and another line here, so it just grazes the circle that way. There are two other important points on Venus's orbit. One of them is here. One of them is here. These 2 points are known as greatest. I'm going to have to write this out. Greatest, let's see, that's going to be eastern elongation. And this is the point of greatest western elongation. Okay, those are 4 conspicuous points in Venus's orbit. Now, elongation, what elongation is it's the angle between the sun and whatever. Okay, so we would say that Jupiter's elongation is such and so, or the moon's elongation is such and so. So if you point to the sun and you point to thing X, whether it's the sun, moon, Venus, whatever, I mean, if you point to the sun, if you point to thing X, whether it's Jupiter or the moon or whatever, the angle between the sun and thing X is called the elongation of X. Okay, elongation of the moon, elongation of whatever. In this case, elongation of Venus. The greatest elongation of Venus is about 48 degrees. In other words, you'll never see Venus further east or west of the sun than about 48 degrees. Now, what this means from our point of view is this. If we now look at the sun and make the sun orange, if we look at this, now this is from our point of view. Okay, so there's the sun. The orbit of Venus stays close to the sun, like that. As it goes around the sun, right, it's sort of in the same direction. So Venus might be here on its way around this way. Having passed inferior conjunction, now it's going to go around towards the back to superior conjunction back behind the sun. But this angle between the sun and that point there, between this point here and this point there, is no more than about 48 degrees. So if you ever point to the sun and Venus, that angle will never be greater than 48 degrees between your two arms, ever. So it goes 48 degrees ahead of the sun, and then goes 48 degrees behind the sun, and then ahead of the sun, and then, I'm sorry, it goes 48 degrees to the west of the sun, and then east of the sun, and then west of the sun, and then east of the sun, so forth and so on like that. Okay? That's a very different motion than, for Mars. We'll talk about Mars soon. But that's a very different motion compared to, say, Mars. It is always near the sun, sometimes running ahead of it on the ecliptic, sometimes behind it on the ecliptic. Now what this means for us from the Earth's point of view is this. If we look east at sunrise, so here's the sun poking his head up over the horizon. Maybe we're at the beach and we're looking east and we see sunrise. Well, the orbit of Venus, so the ecliptic is actually going to run like something like, let me get a different color here. The ecliptic is going to run off like this. That's the ecliptic. So what that means is that the orbit of Venus is going to stretch out this way to the west and then sort of be back behind under the horizon like that. All I've done is take this picture here and tilt it. Okay, as the sun's now coming up. Sun's going to come up along the ecliptic, Venus is coming with it. So when Venus is to the west of the sun, it rises before the sun, because this whole thing came up with the sun, right? The sun and all the planets with it are moving this way, rising. You saw this in one of your early labs, maybe lab number 2. You saw the stars and the sun rising up and to the right, looking east. And so when Venus is on its the western side of the sun, it rises before the sun, so you can see it. Okay? And it will also move around and set before the sun, in this case. But if Venus is over here, on the eastern side of the sun, then you won't see it, because the sun will rise first, and by the time Venus rises behind it, the sky is already too bright to see Venus. You will only see Venus in the morning when it's to the west of the sun, on this side of its orbit, near the side of the west. Right, in this picture here, this is the west, this is the east. So in the mornings, you see the Venus first, and then the sun rises behind it. This is when Venus is known as the morning star. Now, of course, it's not really a star. That's just a poetic way of referring to it. Okay, that's when Venus is on its western side of the sun. So here's the western side of the sun. Here's the eastern side of the sun. Right, west is back there. So if we look to the west at sunset, here again is the sun. Going down. Okay. This is the west at sunset. Right, now it's all moving down and to the right. The ecliptic is now like this. Let me get the green one. The ecliptic is now like this. And the orbit of Venus now, the eastern side of it is visible. The western side of it is under the horizon, like that. Now when Venus is on the eastern side of the sun, like this, after the sun goes down and the sky gets dark, we can see Venus. This is when Venus is known as the evening star. It's the same thing, of course. It's still Venus, but it's called the evening star when it's to the left or the east of the sun. Okay, and so it sets after the sun, because in this case, right, everything is going down to the right. the sun is going down to the right, sinking behind the horizon, carrying Venus with it. Okay, so in this case, when Venus is to the east of the sun sets first, and we see Venus, but not for long because the whole thing continues to set. Whole thing continues to set. But when Venus is on the western side of the sun, when it's down here, it sets before the sun does, so we never see it. Okay. So when it's in the east of when it's to the east of the sun, we see it as the evening star. Okay. In the western direction. You know, if we look to the west, we see the sunset. If Venus is to the east of the sun, that means it'll still be above the horizon. But it will set quickly. If we're at sunrise and we look over and Venus is to the west of the sun, it will rise first. And so looking to the west before sunrise, we'll see Venus come up, and only after that the sun will come up. But as soon as the sun comes up, we don't see Venus anymore because the sky gets bright. So Venus is both the morning star and the evening star. And the most you can see Venus before or after the sun is about 3 hours. Even at its best, you can only see Venus for about 3 hours after sunset or at about 3 hours before sunrise. You'll never see Venus at midnight. Okay. It will either have not risen yet or it will have already set, one or the other. The same thing happens, by the way, with Mercury, but it's not as obvious. Mercury is much smaller, much further away, not nearly as reflective as Venus, so it's a lot harder to see. And also, it stays much, much closer to the sun. So it's more of a subtle deal with Mercury. With Venus, it's right in your face and very obvious. But all the same terms apply. Greatest western elongation, greatest eastern elongation. For Mercury, they all apply. There's a superior and inferior conjunction. For Mercury, the greatest elongation, east or west, is 28 degrees. For Venus, it's 48. For Mercury, it's 28. It stays much closer to the sun than Venus does. All right, that's it for Venus. Next up, Mars.